Okay, so this week we're gonna cover Unit 3. As we were behind a couple of weeks, right? One for the holiday and one I was sick. So in this week, we're gonna talk about networking components, addressing a few areas, especially with network interface configuration. So we'll start with the network adapter. And I think many of you have taken CIS25. So we talked about the network adapter in the OSI layer. It belongs to the physical layer, the first layer. Network adapter is important. Traditionally, we would use a dial-up modem, like in the older computers. Then eventually now we all integrated network interface card, which uses Ethernet standards. And also in the past, you have seen legacy system using coaxial adapter for cable modems, which some of you have made coaxial cable last time. So it is really a device that we attach or install on the system. And it does data encapsulation or preparing your data, zero and ones, to be able to transport. So as it gets to the switch, right, that will get framed, and we touched on the OSI last time. So what you would see is you would see that at the copper wire level, it converts your outbound data and format it so that way it would fit the bus architecture. So if you install, most of us put the Ethernet adapter onto a bus, which is a slot on the motherboard, right? And that bus is either PCI Express or in the older system that will be PCI. So that bus would have a certain width. Think of them as lanes that can be transmitted with data. So if you're using Express X16, which is 16 lanes, we're able to transmit faster data. But because of the standardization for Ethernet 802.3, we often see that it would just scale, right, based on the standard requirement. So this is what you see when you look at a network interface card. On the left-hand side, you see that it has multiple Ethernet connection. This is an adapter that belongs to a server system. So server system would have more inbound and outbound traffic. For example, I would have a server system on a rack, and that would serve the purpose of web, where it receives a lot of requests, right? After it's being routed in, so you would see that the adapter on the server system would have multiple Ethernet connection. And what you can do is we'll talk a little bit about how we can group them. So in the server operating system, you can configure it where you can team the NIC. And in a lot of the security appliances and the network appliances where you can group the network adapters, multiple adapter together to be able to control a certain type of traffic. So let's think about like how, how we drive on the freeway and there's like 4 or 5 lanes going each way, right? So let's say that we can say that those 4 or 5 lanes is only for outbound, and the other side 4 or 5 lanes is only for inbound. So we can group or team NIC, network interface card. All right, let's go through and answer some questions. Okay, so for number 1, it says, describe the functionality of your network interface card, your NIC. And you can find this on the page 1 of your notes. It is a device that is preparing your data for transmission from your computer system. So the data is prepared for to be transported onto the copper wire by converting the outbound data from parallel format, which is the width of the architecture bus because it's dual, right? And into electrical signals. So it needs to transmit it as 0 and 1s because it's being sent through the wire. Because when we plug in our Ethernet adapter, right, to the cable is then connecting to maybe our wireless router, or in your case, it's connecting to the jack in the wall, and that gets transmitted through the wire, so it needs to break it down into 0 and 1s. Now, on the receiving end, if you're receiving your data, if your system is receiving the data, the network adapter needs to convert the electrical signal back into data format. So let's say that I am sending an email, right? That email is going to get stored on first it started from my application on my system. Then when it gets transmitted, it's gonna go to the network adapter, network interface card, converted the data into 0 and 1, transmitted onto the wire, sends it through the network and multiple network until it gets to the server, right? And the server transported to eventually the network of the destination system. The receiving system, right? After receiving the data frame, the payload, the data, which is the email itself, is then being received as electrical signal. The network adapter, its job is to convert it back into data, so that way you can see the email. Right, so all of that is done in microseconds based on our standards today for our speed. So encapsulation and decapsulation happens within the system and its device. And we see this with the wireless adapter as well. But wireless is transmitted through radio frequency through the air instead of through the actual physical copper wire. So your transmission through the air is a little bit less in the speed, even though we say 5G, right? The stability in the radio frequency is not always the same, as you know that the wavelengths also change. But electrical signal frequency is not 100% the same, right? You see that sometimes it's lower, it's higher. I don't know if you ever able to measure your frequency in your household electricity. You would see that it's varying, right? So you know, this is what we talked about, burnout and other things with spike in when we're connecting power. But through the copper wire, the job of the NIC is just to make sure that it's converted to electrical signal and being sent, right? Because now our network is all digitized. So anything in other type of signal format needs to be encapsulated and decapsulated. Any question? Okay, you can find this information from the first section of your notes before the pictures. The next part, it talks about transceiver. So this is a way that we can interface and receive electrical signal across the transmission media. So when it receives the signal through the wire, it would then sends it to the local system. So what we would see is we would have different type of transceiver. The next picture shows you the onboard transceiver. I put the arrow here as you see that the adapter would have a different type of media like coaxial, or sometimes you do see fiber optics and other type of medium that's used. So these transceivers, the media connector is built right onto the back of the network interface card. So this is an older adapter, as you can see, and it would have a transceiver added on. So some network interface card has that integrated, especially the older network interface card. So when you are looking at not on board, right? Most of the time we buy a motherboard and it already has a network adapter built in. But if it is an add-on adapter like this one or the other one, but this one has a transceiver. Now, if you use an external transceiver, let's say that your adapter doesn't have it and you need one, you would need to get one externally. and it will look something like this. I do see a lot of this in networks, the SFP. So these are just attachment that you can use to the connector that allows you to integrate the transceiver as part of your network devices. Let's say that I need it on one of my network appliance. I can buy the module, which is like a separate attachment, and I can add that onto my appliance. Okay, but the important part is you need to look at the type of cable or connector that's connecting to your transceiver here to see if it will work with your existing network. So we need to describe the differences between an onboard and an external transceiver. The onboard transceiver is built onto the NIC, or the network interface card, NIC. And with these transceivers, the media connector is built onto the back of the NIC. So when you look at where you plug in your Ethernet cable, you would see that there's a cable for the transceiver. Right? It is an additional connection that's built onto that network adapter. An external transceiver are actual media connection, which is made, right, as an add-on, so you can have it as an external transceiver that connects to the device. So the benefit of it is that the vendor of the device, such as the router or the switch, doesn't need to hard code specific port type. So you can just attach that to a switch or a router that needs that additional transceiver. Let me correct this. Okay. So you can have it built on or built in, or you can have it externally adapted to your network appliance. Any questions? We have to be able to recognize the type of cable, right? Their speed, the type of components in network systems like network adapter or network interface card, transceivers, and so on, for certifications and for work. So ultimately, these components at the first part of the notes basically address signal transmission from and to the system, right? Whether it is a PC or a server or a router or a switch. So your server would have network interface cards as well. And then the switch and the router would have connection to different cables, but for the functionality of sending, right, the data to the appropriate destination. Any question? And you can find this information on page 1 of our notes. I just summarized some of that, right? So here it tells you that the newer router, the switches would have appropriate connection type. So it would have the SFP port already incorporated. So that allows you to connect a transceiver to it. And it is 1000 base T for copper. So you really, when you were shopping for network devices for upgrades, we always want to look at the type of cable that's being used, because ultimately that's how fast our data is going to go across the networks, right? Okay. So there are some of the newer, more modern transceiver types. You got the SFP, the SFP Plus, which has an enhanced form factor and it does transfer rate at a higher speed. And then you got the QSFP, which is a quad. Q stands for quad, small form factor. And you see that an upgrade from the SFP to SFP Plus for the quad, it's quadruple the speed. So of course, that's going to come with the higher price. And if your appliance is able to connect, we just got to make sure that it's able to adapt to SFP. And then you got the GBIC, which allows you to convert for gigabit. And so that supports a transfer rate of 1 gig. That seems small for you, but back then, if you have an older network appliance, that's a big deal. We're able to amp up the speed. And it is a hot swappable technology. So when you hear the term hot swap, what does it mean to you? Hot swap means what?
Don't have to power off.
Yeah, you don't have to power off. I can switch the device even when it's on, right? It sounds unsafe, but it's definitely doable for drives and some of the appliance. Very good. Thank you, Alex. Okay, so some more picture for you to see. All right, let's talk about some configuration and network adapter troubleshooting. Exam for certification loves asking questions about troubleshooting. Also, employers, especially for IT people, they like asking about troubleshooting. Okay. So automatically by default, the auto configuration is on because it's allowing the system to auto sense. And it's able to configure itself, but you can manually configure for sure. So when you're troubleshooting, you want to look at the setting first to see if you should change it. And with that, it's gonna determine the speed that the device is connected to. And a lot of it comes down to the bus speed, right? I can have a fast car, but I cannot drive on a faster road because the road is not built for it. So the road is really your bus length, the width. So if you set it on auto, it's going to try to determine how fast it should be able to submit or transport data. So ultimately, you want to really look at the property of the device or the adapter and be able to either manually set the speed or have it auto configure. And if auto configuration doesn't work out, then you have to manually set it. Okay. So next part. When troubleshooting network interface card that has multiple types of connector, what should you do? You should change the configuration from auto to the currently using connection type. Because sometimes the device itself cannot detect the specific connectors or the connector that's using a certain media with the speed. So auto can, impede the device from properly being connected. So we have to go into its properties, and we'll do some of that today. Change the configuration from auto to the specified connection type or the connection type that you're using. The currently used, I should say, connection type. Because the auto will not allow it to fully detect, right? We want to set up what kind of connection we should have. So in the next section of the notes, since it's covering next, I'll just go through this. This is gonna come up on final and quiz. It's gonna come up on certification. So we wanna make sure we know the transmission methods. Because in communication, whether you're talking about analog, wireless, or even, networking, you see that a lot of these transmission method is being repeated throughout because we base it on the same method over time. Simplex allows communication in one direction only. Send only or receive only. It cannot do both. Simplex only allows you to have one direction. It's like one-way street. You can only enter but not exit. Or you can only exit but not enter. That's simplex. Then you have half duplex. It's able to allow both directions, send and receive, but not at the same time. So it would negotiate, right? Like, so you would have one can send, and then when that's done, the other one can send, right? So it's not both ways. So concurrently, it cannot happen. So half duplex can send and receive. It sends and then it reads, right? Simplex, it can only send or it can only receive. For the full duplex, it can send and receive simultaneously, same time, concurrently. So when you're looking at your network adapter, if it is a network interface card that only is a simplex for transmission, is able to only use simplex for transmission, that means that it can only send. So you say, why did they make this? I mean, communication should go both ways. Well, there are systems that only broadcast. It sends to the other system. It doesn't matter if the other system receives it or not, right? Who cares? Sends to everybody, like broadcast radio. Whether you listen to it or not, doesn't really matter. So simplex works that way. There is also half duplex network adapter that's able to send and then receive, or receive and then send, not at the same time. So it's able to receive data, right? And then send the data, but it's not able to receive while sending. So half duplex setting, if you see this setting, you should know that it does slow it down because in the case if your system needs to send and receive, you need to make sure it is full duplex. And then the full duplex is able to receive data while sending. So it uses all four wires, or all four pairs in the wires that there are 8, right? And so when you were making the cable last time, you untwist the wires and then you toss them, because the pin location really refers to how the signal is transmitted. And so when you connecting computer to computer, you want crossover, and the color wire really represent the type of signal that's being transmitted at which pin, okay? So full duplex is going to give you the highest throughput because it is able to communicate simultaneously, send and receive at the same time. Now, why would I need to use a half duplex? If you want to regulate traffic, if you want things to be slowing down, if you want to control, right, what is being sent, maybe for monitoring purposes, or, there are some needs for the half duplex, then you can configure your network adapter to have that, for that method. But for most use, we would use full duplex for the highest throughput, the highest speed. Any question? You can find this also in our notes. Make sure we remember these. Okay. Okay, so we can find the transmission methods on page 3 of our notes. So you can find that there. Just the verbiage is a little longer. And in the next part, we're gonna talk about MAC address. You're gonna do some of this with the lab today. I did show you how you'll be able to find your IP address and your MAC address information. So the MAC address is already been assigned, or they say burn in, but really programmed into your network adapter, your wireless adapter from the vendor, right? They're saying that eventually we'll run out of MAC address because we have so many devices in the world, right? Schematically, but I think if you're looking at the probability in using the hexadecimal, I think we still have some room. So let's say Dell or whoever, a lot of times we buy adapter from a Chinese company, and then Dell would, put their label on it and build that into their system and then ship out their system. So sometime when you are looking at a MAC address, you might see a vendor in some part of China, but your computer is Dell or HP or another brand, right? So don't be surprised. So MAC address have 48-bit length. These numbers are hexadecimal, that is a base 16 format. So 0 through 9, A through F, right? It consists of 12 characters. So when you're looking at the breakdown for this, right? The first 3 bytes of the address, that's your OUI, Organizational Unique Identifier. This is important for security people. Why? Because when we need a track system, we can find out more about the MAC address, what that system is, right? Let's say that it's assigned to Dell. We know that the targeted system is going to be the Dell system, right? So when you're monitoring the network, you saw this on Wireshark last time when things are popping up, and all of a sudden it shows Cisco, right? IBM server, etc. How does it know that? Well, it's looking at the addresses, and that's how it's able, the unique identifier for that vendor, that's how it can tell it's a Cisco device, right? And then also how they identify that inside the network as well. And then the later 3 bytes, the last part here, the least significant byte, that's going to be unique address to that adapter. Okay? So you're going to see when it has the 0, it's going to be unicast. When it has 1, it's a multicast. So unicast, it's 1-to-1. Send 1-to-1. Multicast, 1 to a group. Okay? So this is how the system is able to differentiate between it's sending directly to a system or it's sending directly to a group of system on that segment. And then for the next bit here, from the least significant bit, you have the global unique identifier. This is where it's enforced. So the 0 is when the OUI is enforced, and the 1 is how it's locally administered. So basically, we're just using electrical signal on or off to be able to distinguish between whether it's OUI enforced or not. right? Locally administered. So I put down some links on your notes to be able to check that out, and we'll do that as part of our lab as well today. Any question regarding MAC address? So when you find your IP address, right? So let's say I do CMD to open up my command prompt like last time. And when you do IP config /all, you're looking at all configuration for IP in your network adapter. This is what's set with the operating system. And what you see is you see your IP version 4 address and sometimes version 6. The physical address is your MAC address, whether you're using wireless or wired, right? So the physical address is your media access controller address. That's what MAC stands for, media access control, okay? Because, and this is operating at layer 2. So what device uses a MAC address? A switch to distinguish which system, right? And the router uses IP. Okay. So how can you determine which manufacturer produced the network adapter card or the network interface card that is installed on your computer? You just locate the MAC address and use OUI lookup tool on the web. So in forensic and risk analysis, let's say you're looking for, you're doing vulnerability assessment and you're trying to determine what system that is, right? Having that MAC address information is important. Normally, a lot of the scanner and the tools that you see is going to give you IP addresses, and then some tools will also give you the lower layer, the layer 2, which gives you the MAC address. And can they spoof that? They sure can, right? There are applications and tools that they can modify or alter the addresses. Now, when a system is connecting to a switch, the switch contains a table on its RAM. It stores which system is communicating, so that way, if it reconnect to that switch, it doesn't need to add in that list again. So it uses as a way to cache some of the communication, so that way it's fast, right? So that switch on that segment is going to store a list of MAC addresses of the systems that are talking to it in that segment of the network, that section of the network. So from an attacker standpoint, what will happen is if they are able to access that switch or even the higher level switch, they're able to map out which systems are connected to that segment. But from a networking standpoint, that table is manageable, and yes, we can remove, right? We can go in and manually delete some of the entry in that table, but that table is truly to maintain the dynamic communication across between the system and the switch, so that way it doesn't have to, reconnect and re-update every single time. Because when you're writing to RAM, that takes time, right? And then updating that, and that switch might be updating other switches as well. And similarly, you have the routing table that stores IP addresses for the system that's communicating with the router. It could be router to router or server to routers, etc. Any question? So this is going to give us the vendor information or the manufacturer information. Okay, so we have some of the lookup tools here. There are quite a few online. Those are the common ones. And here it talks about the testing phase. So you make sure that you check your connection with the cable. if the cable is connected. So how do I know if my network adapter is working, right? You have that LED light. I'm sure that we talk about this in CIS25. When you don't have network connection, few things you need to check. Does it have power and is it connected to a cable, right? Those two things first is gonna resolve a lot of the issue, because sometimes when things get moved, cable gets disconnected or things lose power. Rarely that you see the adapter that goes bad, but once in a while you do have an adapter that eventually get old enough and use enough that it goes bad and you have to replace it. But look at the LED light. When it's transmitting, it should be green. When it's idling, it should be yellow, right? So some of the common sense going to troubleshooting the adapter, etc. So here it talks about the connection light. Those are the LED lights. And then the higher, so it's blinking green and it's sending, and sometimes, it goes into yellow, but a lot of the times when it's blinking green, that means it's talking, it's communicating, it's sending 0 and 1s, right? So you can use some of that diagnostic program. Loopback test is a way that we can test whether the card can send out and receive back. So when you do a loopback, you send it and it comes right back to it. It's a way that we test. Now, in some network, they disable this because it just takes up bandwidth for loopback tests. And so somebody can also use the loopback test to floor your network. So, but yeah, we can use loopback tests to send it out and come right back to the actual adapter. Okay. I can move this down to the next line in case you're still recording that. Okay, so how should you troubleshoot a network interface card? Check the cable connection to the Ethernet card. So your Ethernet cable to the Ethernet adapter. Check your link flag to verify physical connection. Is the link flag on blinking? And then you go into the software level. So always check with hardware, right? When you have connectivity problems first. Then we're gonna go into the software troubleshooting where we get into the OS settings. We would check the network interface configuration for the IP address. What if it's set to a manual address and that address is already being used, or is it duplicated in the network? It's gonna take down both systems, not just one. So if I set this computer to have the same IP as this computer, guess what's gonna happen? Both of them are gonna be out, right? We should not have a duplicated addresses on the network. Now, if you're using dynamic address configuration, then it should be able to obtain an address from DHCP system or server. So we can go into the network adapter configuration for the IP address. We'll look at that today. You can also do a ping with the loopback address, 127.0.0.1. That's a loopback address. It's gonna go out and come right back to that system. When you're doing a ping, we're just gonna send, in Windows system, it's gonna send 4 packets, 4 requests to itself. And for each request, it's gonna wait for reply, right? So I can do ping 127.0.0.1. It's gonna send 1 request. If it's connected, it's gonna say reply, right? And this is the amount of time, so we can check, we can look at that shortly. You can also run diagnostic program, and in Microsoft Windows OS, you can use Windows troubleshooting problem. And sometimes you will get the connection notification, and then you can click on it, and it basically walks you through the troubleshooting center by Windows OS. And then, or you can go through network and internet configuration in control panel or in Windows settings. So Windows setting is something kind of new, and that's layered on top of control panel. But control panel has always been around as part of a tool that we would use to configure or control our system. So make sure we know these things when we're interviewing, when we're taking examination for certification, and we're taking quiz or exam for this class. Okay. So I think I demoed this last time, right? Coming back to my command prompt here. And I can do ping 127.0.0.1. That's a loopback address. And so you notice here that it sends 4 requests because Windows operating system is designed this way. It sends 1 packet to itself and it got it's received. Okay, so that's successful. Same thing, the second packet, third, and fourth. So here it tells me that it sent 4 and it received 4, lost 0. It's 100% successful. That means what? My system is connected. I'm receiving signal, right? Now, can I do the same thing with the IP address up here? So let me look. I'm on the 192. I thought, okay. Oh, that's something else. Okay. 10.111.83.131. Now, the difference between this and a loopback address is the loopback address, it just, refer back to the host itself, where this, it sees it as an IP to a destination, but it's still its own IP. It's my own computer that pinging myself, right? Now, see, when it's doing the request timeout, did I put that correctly? Hold on, let me check. Yeah. 83. I put 183, sorry. So when you have an incorrect address, if it's not successful, it's going to time out like this. That means that it's not connected, right? So the IP address might not even be alive. So now I'm seeing response, right? So when you ping, and if it's timing out, then that means it's not connected. When you ping that it's successful, it's going to get 4 reply. Now in Linux system, when you ping, it just keeps pinging. It keeps sending requests, waiting for reply, and it keeps going until unless you put in the counter on how many times you want to ping as an option in your command, or you have to stop it. Okay. Okay, so we saw a little bit of pinging there. Okay. So before we answer that, let's look at this real quick. I want to address driver real quick. So it's very important that when you install an adapter, install the driver, right? The driver is the software that's going to allow the OS, the operating system, to see what device it is. Now, even if Microsoft or the operating system provides a generic driver, you should download and install the driver because the driver usually contains full features, and that's going to allow the device to have maximum, you can utilize it to its max capability. If you use the generic driver, it still be functional, but it might not give you the options. And this happens a lot with display adapter or video card, right? If you use a video adapter, you're able to accelerate it, change it, whatever, right? Configure it for your games or other things. So network adapter, similarly, you need to install the driver, especially when you're upgrading operating system. So you can do this through device manager, and you guys might not be able to access device manager if you don't know. In Windows system, you just search for it. right? You might not have administrator privilege. So in device manager, it's gonna list all the devices that's connected, right? And seen by the operating system in my computer. Whenever that you see an exclamation point like this one, then, or something that is with an X, that means it's disabled or something needs to be troubleshooted, okay? So device manager allows me to list all the components in my system. And here's my network adapter. If you expand it, if it's configured, it should tell you this, okay? Okay, so I talked a little bit about the hub and how it's different than a switch, right? The hub is not as smart. It is able to forward the traffic to the other system. It's usually a central point or it's used in a star topology. So it's also known as a concentrator, and it would look similar to a switch, but it doesn't have the capability that the switch does. It just sends a signal to the intended system, and in the case that there's collision or other things, right? It's not going to be able to resend. Okay, and collision in the system is in the network is very common. So what we can connect two hubs together, right? So we can chain them together. We can connect multiple things together. Remember that when you connect two things together, right, you need a crossover cable if they are the same type of system. So if you want 24 port hubs, you can set it up as an uplink port 24 for the first hub, then connect that to the second hub to any other port. So let's say that my hub has 8 ports, right? The last port number 8, is going to be my uplink port. I don't use that for other things. That's just for uplink, connected back to the network. Port number 7, I can connect that to the second hub, right? And we would do that subsequently. We reserve a port that's going to connect back to the network because we attach it to the network. Does that make sense? Because we chain it back to the network. And then another port to chain them together, okay? Now, when you do it this way, that's called cascading. Is it common? You still see it around, but most hub has gone out a while ago. And if there are on the network, it will be 4 sub-networks. So it's going to look like this. So you can use any other port to chain them together outside of the uplink port. Okay. All right. So let's answer that one question. So how do you connect 3 hubs that consist, let's take out the S, of 8 ports? We connect the uplink port 8 to the first hub, or on of the first hub to any port of the second hub. Then use the port 8 on the second hub and connect that to the uplink of the first port on the third hub. Like the picture. If you look at the picture, it makes more sense. So we have an uplink port. Let's say the last port on that hub. We're going to connect it to any other port on the second hub. We're going to chain that together. Then we're going to use port 8 on the second hub and connect that to the first port on the third hub. And you want it to do schematically so that way you don't just plug it into port 2 or port 5 or whatever, right? 8 to 1, right? 8 to 1. See? So that way it's a lot easier to remember, oh, port 8 was the uplink from the first one. Port 1 is the second one that's chained to the first one. And then port 8 on the second one is going to chain to port 1 on the third one. Right? So last to first, and that's how you chain them together. So if I want to kill your connection, right? I look for the port that's being chained. Or flood your hub. So in order to protect the network, we have to understand network devices and how they work, because the attacker, they definitely do. And they understand what you use, or as soon as they find out what you use, they will target what you use. Okay. And that's how network gets taken down or circumvented. So to have a good network defense, to really understand how your system works and how they communicate, and then set up boundaries and measure across, right? Not just one area, but, we do in-depth security in multiple areas, so that way we don't have single point failure or, single targeted point. Security, it really comes back to the network, ultimately, everything, right? Whether you're doing web application or everything, so it's the foundation to all communication. So any question? Okay, so let's talk about active and passive hub. A passive hub contains no power source or electrical components. There's no signal processing. There's no regeneration of signal to the destination. So it doesn't really have its own electrical component. An active hub has a power source. It has a built-in repeaters to boost, or an amplifier to boost the signal. So it's able to regenerate or amplify the signal. That is the active hub. A lot of the ones in the market today are active hubs, the majority. So hubs were very popular in 1990s era, because we had switch, but I think transition from 80s to 90s, a lot of the network has hub. And so we would face with a lot of collision issues, and we have to, when we do quality assurance for networks, we want to make sure that we control collisions. So this is why you see the technology with collision control interface type of devices that was very popular, was built for that purposes, because the network has a lot of collision. Any question? No question? Okay, so active and passive hub right here, right? It gives you additional details. 8-port hub receive data on port 3 and resends the data to port 1, 2, 4, 5, 6, 7, and 8. So it when it receives the data on one port, it sends it to all the other ports. So the hub is, it's noisy. It's gonna be like the way that I remember it when I first learned networking. is it's like your nosy neighbor, right? Tells the story to everybody once it heard the story. So when it received data on one, it's gonna send it to all the others. So the passive hub, no power information is there. It simply is attached to a port and it uses the signal that's generated from another device. That's how it's able to send that signal forward, right? So it doesn't have its own power source. So that means that it has to attach it to another system where it's going to be able to receive the data or just receive the bits. The active hub information is here, and it's often used as a multi-port repeater. Remember, the hub is, right, like the nosy neighbor. Hear one story and tell to everybody, right? Like, so multi-port repeater, it still sends it to all the ports. Now, when you're running hubs, you usually would use, we now use Ethernet cable, and that's going to limit you to 100 meters. Okay, so let's touch on the next question. It says, in a network, what is the purpose of a repeater? Where should it be placed? Repeater is its function is exactly as its name. It repeats signal, regenerates signal, rebuild signal. So repeater will rebuild the signal, allowing it to travel the extra distance. So when do I need that? Well, I might have signal degradation because there might be something that's impeding it. You see this a lot with wireless because wireless things like plated metal wall will bounce signal, glass will bounce signal, and water will bounce signal. Or at the end of your termination, maybe that's really far, like 100 meters away from your source, you might lose some signal. So what we want is we want to place a repeater there so that way we can pick up that signal and generate it further, right? Because the farther you are from the source for most part, also you have to consider like other interference in electrical signal. Like I said, if you have a bundle of cable together, you are going to have leaks and you're going to have interference, right? A lot of electrical devices together, you're going to have interference with signal. So the repeater simply allows us to take it the extra distance. It should be placed before the maximum distance of the cable or the signal range. So that means, let's say I'm using Ethernet cable and I run it 100 meters. But before the 100th meter, right, the 99 meter, I need to place my repeater there. So that way it can take that signal and extend it to the next part of the network, which requires more than 100 meter. Okay. I would not design it that way, but in the case that you don't have a choice when you get into the network, somebody designed it, you have to fix it. That's the majority of the things in network administration and also in security. We fix things that somebody else created or, that there are existing problem already as it's created. So we go in and we fix the problem. So understanding that, right, where should I place it before the end of that distance, right? You don't want to go all the way to the end. You want to have a little bit of room because that signal is then going to be repeated. So that part is for the repeater. Okay. And you can find that here. Let's talk about bridge and switches. So when we're connecting the two devices together, we call that a bridge. So let's say that in my network, right, I have a router. Traditionally, I might have a big switch, and then I have some segment switch. But one big switch, it might be too much to handle, and you have a bottleneck there because it funnel back to one device, and then the router routes out, right? So it gets congested there. It's like 15 lanes and then you merge it all into one lane. So it's gonna slow it down. What we can do is we can add another switch and we can divide up the traffic, right? On both sides and then funnel that back to two routers or multiple routers. So what type of addresses are used? I don't know why I have so many grammatical error in these are used by the bridge to determine the network segment of the destination system. How does it use the address to filter the system connection? So remember I talked about how switch uses MAC address earlier because it stores that onto its table to determine who's connected. When the system doesn't connect anymore, it becomes a stale connection, and you can see that on the switch table. So MAC addresses are used in a switch in general, but when you bridge it, it's really determined which destination segment. Remember, I might have two switches, right? When we're bridging, we're just connecting a switch to another switch, kind of like cascading the hub, right? So how does it know that it's switch number 1, switch number 2, or switch number 3? Well, the MAC addresses says that. Because all switch has a table. Let's say that switch 1 has a table of segment number 1. And segment number 1 has this list of MAC addresses. So it's looking at the MAC address to determine, oh, it's not my segment, pass it to switch 2 or 3, right? So it's looking at that for comparison so it knows which system is in that segment based on the MAC addresses. And that's really important. So here it talks about that. And it talks about how it's stored it onto a table. And that's basically RAM. Okay. And that is used to filter the location for the destination. So basically the table is going to tell you which switch is going to handle that traffic, that communication for the segment, right? Switch 1, switch 2, or switch 3. It's the MAC address. Because it's already either stored on the table, so if it doesn't have a match, it passes over. Now, right? So a lot of this is important. We know that it's stored this. So when you do footprinting and you do tracing people, how can you trace it back to which system, what part of the network has that problem, right? Let's say malware, or attacked and etc. You look at the switch table, okay? So we know that, so how can it detect? If software doesn't detect your malware coming in and if there's irregular activity, disconnect, right? Logically and physically, pull the cable. So here, you know that that's stored on RAM and you can always check the switch table as an administrator or, network technician. You can find that information inside the switch itself. And also when the system communicate with the switch, it also store, right? That table, it's going to say it connect with that device and that device communicate with it. It's two-way communication. Okay. But then we can also do forensic with RAM, in the case that, if you want to find the table. So and this is volatile though. So when you turn that off, it goes away, right? So many things can be beneficial on both sides, right? As when we understand the pieces of the puzzle, we're gonna know how the games can be played, right? Okay, question. Let me push this down a little bit when we move forward. Okay, so why would we use the switch to connect systems, devices, instead of a hub? Because it gives you more stability, ultimately security because it's availability. since transmissions are not sent to every port on the switch, it's not sending to all the systems. So in a hub, you send from one, all the other systems receive the same thing, right? You don't want that. You want privacy. And because administrator can control which system can connect to each switch port. So if I have a 24 port switch and I have 20 computers, I know which computer is connecting to which port. And I can disable the extra port that doesn't have connection because potentially that's a physical vulnerability, right? So we can administer how the system is physically connecting to that switch. The hub cannot, right? You connect to it, it receives signal. The only way that you administer it is not connect, but unplug. The bandwidth with the standard hub is shared by all the users connected to the hub because it's shared information that's sent across. So as far as speed and bandwidth goes, it's whatever the hub can provide across all the systems that it's communicating with or connect to. A switch, all users get full network bandwidth. We're able to control more bandwidth with a switch. So definitely beneficial because it is a later technology and there's more development in it as we continue to use it. We can have a layer 4 switch, we can have a layer 2 switch. We can have, interchange use with the layer 4 and the layer 2. So if I buy a layer 4, I can use it at a lower level, but it does have additional features for layer 4. So definitely switch would be a better option if you want more privacy in your system communication, more reliability, more administration and control. So ultimately, we see the benefit in using a switch versus a hub. We would use a hub if that's the only choice you have, or that would be a purpose. You transmit from one system to all the systems that will receive. So with that, we would bring it to VLANs. In some switches, we should be able to set it up a virtual local area network. Basically, it is a logical network through one port. Let's say that I have a 24 port switch. I wanted to take port number 23 and make it a virtual LAN. And connect another switch to it and be able to set up all of these computers connected to it. So we can isolate that network and monitor that network. Virtual local area network is beneficial for isolation purposes, monitoring purposes, controlling, or even scaling purposes. One of the benefits that you see for a virtual local area network is to minimize traffic within or across the switch. Because let's say that I need to have 48 system connections, right? What I can do is I can control some connection through certain ports. I can, let's say, put 12 computers onto a virtual local area network for the VLAN that's connecting to port 23, another 12 on 22, another 12 on whatever, right? 20, 20, 21. And then another 12 on 20. So I would then have 48. But I can control those 4 physical ports on that switch and be able to monitor it and regulate the traffic through that actual physical port by configuration. Okay. And it also allows you to separate the traffic because if we place 12 on each one, that could be departmental use, that could be location or regional use. So VLAN can be, very beneficial. So when I first came here, right, I asked for a darknet Because I said, I don't want my students to be limited to the things that they download, to things that go through the district, because that would be considered risque, right? Because a lot of the things we do is risque, right? Like I do malware analysis in my class when we actually have malware traffic, right? But on a virtual machine, well, we do it with protected measures. So, they have their network administrator and security people came down and check out this room. And I said, it's really simple. You give me a port, put it on a VLAN, control that, put it through the firewall and done. So I talked to Jared and he's like, how many ports do you need? And I was like, maybe one or two, but this whole entire lab needs to go, and then the SAS214 needs to go on the darknet. And that's what we exist. You're actually using VLANs, right? So they control and they monitor that port, not that they don't because we're on the darknet. It's just isolated with the rest of the student network, even though you still see yourself as part of the student network because you can log in, you can check your email, you can do everything because your traffic, your request still funnel back to the regular white side of the network compared to the dark side of the network, right? There are certain traffic that is controlled. So, because I've worked at other colleges where you can't even download Kali Linux. I know that school district would that happen, and it's just such a cumbersome thing to really learn industry tools without having access to industry tools, right? So we're on VLANs. And you can do that for isolation purposes, monitoring, control, managing data, many things. Any questions? We'll do a couple of labs on VLANs. I know that if you're taking 40B after this class, it's useful to take 40B after this class. You are going to do a lot of VLANs in routing and switching. That's switching area is all about VLANs, right? Okay. And it works with a lot of Cisco protocols as well. Okay, so switches and VLANs information is here. So you can do that. You can set it up, for a device as a router. If it's a layer 4 switch, it gives you some additional information. You can have broadcasts to every port as a switch or a hub. So that means that if you want to set up a VLAN on the switch, you need to have a managed switch. When we buy a switch, we gotta look, right? They look the same physically. And a managed switch just basically allows you to have configuration. A lot of the time they would have their own operating system. They are embedded system running Linux with command line in the back. Cisco does that, right? If you're looking at other security appliances, very similar in command and also embedded system using embedded Linux. Okay. So spanning tree protocol, it uses layer 2, which is our switching layer, and it prevents loop on the network. So this is why STP is often used when you have a lot of switch connecting. So the benefits of STP. We need to know this for Network Plus certification and Cisco certification for sure. STP is to really ultimately prevent loop. Because loop uses bandwidth and it is taking up, it could cause problem with your network disconnection and so on. When you're connecting a lot of switches together, you should try to integrate STP. So how do I do this? Well, in the configuration, you enable STP because that switch is capable of utilizing this particular protocol. We talked about protocols or rules that the system operates by, right? So if you buy a switch and it has the capability of using STP, we would enable that option and configure that option, right? Through that management console for the switch. So what does it mean? It is a protocol that examines the other ports to create a loop and then place it only to one port to block to the blocking state. So it makes a loop and put it there and block it so that no data traffic can pass through that port. So once that port has a blocking state, then the loop is broken. So instead of trying to prevent loops other ways, it makes a loop, set it to a port, block that port, and be done with. Right? That's a way that it can prevent loops. So that means that your network becomes more stable. When the port is in a blocking state, if the other links go down, the port is then transitioned to a forwarding state automatically. So it keeps on the roll. It stands in as a forwarding port in case the other connection is down. So that means that it's able to receive and send through that port. So it's like a backup send and receive port when the other ones go down, when it becomes a blocking state. When you set up VLAN, you also see the option for trunking with the T, like tree trunk. Trunking allows you to connect switches together and then assign one port as a trunk port. This port is used to carry VLAN traffic to the other switch. And VLANs are allowed to contain ports that are from multiple switches in the family. So you can have switches connecting together in a VLAN environment through trunking. Now it is also depending on the type of the switch that's capable of doing that. Some switches limited to, this technology and that technology. So if you want trunking, you gotta make sure that your switch is capable of trunking. And it is somewhat of an older technology for VLAN, but it still exists. And then some switch, you can only trunk at specific ports. So if it doesn't have a port for trunking, it would default to a port that can be configured and it's always gonna be that port. You see. Then you have ISL and 802.1Q. This is known as inter-switch link. This is Cisco technology. And it's a protocol for tagging packets that is particularly to a certain VLAN on an older switch. 802.1Q is the standard for trunking. So this is before trunking, right? So when you see 802.1Q, you just know that it is a technology that would be used on an older switch for VLAN, and they have upgraded that. So now most of the switches use 802.1Q for tagging method. So we would see this on Cisco switches only. Port mirroring is a big deal in security, right? We talked about and network administration. Port mirroring is allowing us to be able to monitor traffic live. So port mirroring allows the switch to send a copy of the data that reaches a certain port to the mirrored or monitored port. So let's say I have a switch, let's say a 12-port switch. My port 11 is a mirror port and port 12 is a monitor port. So all the data is sent, let's say for the dark web to port 11, is then copied to 12 for examination. It's gonna look clean. So what does that do for me? When you do that, port monitoring allows administrator to plug a workstation into that port, copy the data being sent, and monitor the network traffic. Right? Because screening through everything can be very overwhelming and difficult. So when you have thousands of systems communicating, a lot of times you're gonna rely on the rules that you set to be able to filter, block, deny, etc. But in the case where if you want to focus on monitoring certain area of your network or a certain time in your network, you can do port mirror and be able to detect. So we do that for baseline analysis because we would take samples of your network traffic and build your data out, right? Because if you capture, let's say I want a whole year of data, I don't want to record the whole year on a PCAP. You know how long that is with Wireshark? That's going to be a huge file. And when you open it up, it's overwhelmingly big, right? So what we can do is we can take sample of it when your network is most busy, the busiest time. We capture that. We can monitor that, and then we sample that, and then we create another sample, maybe at a different time that is also importantly busy. If you have a spike in traffic, you take a sample of that. So ultimately, you build out the baseline for your data, looking at this is basically how it should be operating at peak, right? And then you can also build out a sample when it's the least and see how you better or improve your network traffic. So now you know what port mirroring is, right? You probably hear that in CIS27 or another class. Then we do port security. That allows administrator to associate the MAC address, which is the physical address of the system, to the port. So that would say computer 5 is to port 18, let's just say. Physically connecting to that segment. Let me see if I can get the last sentence in here. No, it's flowing into the next page. So you can set a port to a system MAC address, so that way you can quickly identify which system is connecting, right, or impacted in the case of the event. Okay, I'm gonna move some of this down because I think it's overflowing to the next page. So we'll start with this one. Sorry. Okay. So port security is just a way we specify the address that's physically the MAC address of the system that is connecting to that port. And then we can automatically or configure that port to be disabled in the case if we want to stop communication from that port. And when the system is not in use or that connection is not in use, we disable the port. That's the practice, right? Your port authentication, it really increases security. How? Because it is allowing only authorized system to connect to specific ports. So that's called port authentication. But port authentication exists because of port security. Earlier, I mentioned a little bit of the routing table. Basically, it stores route information, which is used to determine how to reach the system at the destination. Just like when you're using your Google map or whichever map system you use, right? It gives you many routes. And then you store that one route in your mind or two routes, right? Like I can go on the freeway, take this exit, and I can get there. Route number 2, I can take this street, turn right on that street, and left on this street, and I can get there. And so you would, so the routing table basically store all the routes. So that way it can quickly determine which route is best to reach the destination. And it could be sending across multiple routers. Usually it does, right? To get from point A to point B. And routers use different protocols as well. So depending on the protocol, right? Sometimes it uses vector, sometimes it's open shortest path, and so on. Now, routing, you can set a route, right? Like I can say, to get from point A to point B, it must be this way. It must be this route, doesn't change. That's a static route. You can have it dynamically route where it could be very certain time in the day where it would be a certain path. So dynamic routing is it can automatically update as it determine maybe shortest distance or whatever that's available, the other routers that could be available to it. So when you look at the routing table, it just tells you the routes on how your data can go from point A to point B, source to destination. So when you do a multi-layer switch, like layer 4 to layer 2 to layer 4, it allows you to be able to control MAC, like MAC to port. Let's say that we talked about that. But layer, when we say layer, that's OSI layer, right? Layer 2 is for switching. Layer 3 is for routing, right? Layer 4 is for transport. So what you see is when a switch is capable of doing layer 3, 4, or even 5 in some cases, you're able to have multifunctionality on that switch. It becomes a router. It's also, you can configure VLANs. There's a lot of different options you can go. So anything higher than layer 3, it can route. So when you're implementing or connecting that switch to the network and configuring it, just know that the layer 4 switch, for example, can route and switch. So that means that it can provide filter and routing on the network. And you see that for voice over IP, we need to integrate like at least layer 4, layer 5 switch. So now if you just want a switch, then just get a layer 2 switch, right? The most you can do with it is set up switch table for port filter. That's good enough, right? For your segment switch, the baby switch, those sometimes are not managed switch. They're just plug in and it just sends. But in the case where if you want more advanced switch, then you can, you can have more functionality as you have a multi-layer switch. So if I want to control collision in my network or domains, we can set up where the switch sends the data to the port of the destination system. That will prevent collision. So we have to set up that port for the receiving, right, from our switch. Because in the case, if it's not, then it could send to other ports on other systems, and that can cause collision. So collision just means that you will have higher chance of error and data loss. Also delay in transmission because the switch normally retransmit. So it just, there is gonna be a lower in your bandwidth, or your network throughput. And then the network device that can be used to create a broadcast domain, we know the term broadcast sends to all, right? Is you can use a router or a multi-layer switch like layer 4 and up with VLAN capability. That's gonna allow you to have a broadcast domain. Any question? So as you can see, this is why there's a second class 40V for just switching and routing, because in network class or a network foundation class, we can't cover enough, because switch and router technology is pretty wide to cover in, you know, just a few chapters. So okay. So while we were wrapping that up, I want to reference, right? So you can see the protocol that we talked about there, port mirroring and port security and authentication there. Then it goes into the section we just covered, the router and multi-layer switch. Read through this, so it gives you more details. And then you can see, right? A lot of the devices now have wireless capability because there's just more demand for it in the smaller or medium-sized business. But you do see more. And then there's the layout for how you can set up in an enterprise network like this. That's just an example on how switches can be connected. And then routers. And then collision and broadcast domain here. So collision domain basically have data colliding, and then broadcast domain. The system can receive from other broadcast messages. So gateway, we cover a little bit of this at the beginning. So gateway is often referred to as a router or a system. It is a way that we can have access to information from another environment. Normally, we would have a router as a system that's going to connect us to the next network. So you often see that the router is a gateway. And my example is that, you know, in order to leave your big mansion, you have to go through a gate. And that gateway is going to lead you to the town or outside of your home. So in a network environment, we would see that it is a router. Sometime in, you know, in some network and in the traditional legacy network, you see that as a server. And so when you see default gateway in the configuration, that is just your router IP address. Okay. Okay. So the purpose of a gateway is to ensure that system in one environment can access information in another. That's the router job, right? By translating information from one format to another. So it doesn't have to be a router. It can be a server, a system, an appliance in some form. So think of it as a translator to the outside world, right? From one world to the next. Almost done, and then we'll take a break. Now, if you want to monitor your network in case of suspicious activity, you can use intrusion detection system, IDS. I know we talk about this in every security class, but IDS is just an alarm system, right? That basically sounds off when you have an intruder. But in security world, when that happens, it's already late. When they can get inside your network, basically, there's an incident already, right? So intrusion detection is a reactive system. That means that it only sounds off when there's an incident, an intruder. The firewall is just a filtering system, so it allows or denies. Firewall operates as using rules, ACL, access control list. And depending on the type of firewall, some firewall inspect packets coming in, being routed in, and it does deep packet inspection. Some firewall looked at port. Some firewall looked at IP addresses. Some firewall look at the content. So depending on the type of firewall that you integrate, it's basically looking at what's coming in or the traffic and determine based on that traffic to see if it's acceptable or not, based on the rules that you set. Now, the primary difference between a passive and an active IDS, an active IDS will monitor activity, log any kind of suspicious activity, and sometimes it would take some corrective action. So it takes on the behavior of an IPS compared to a normal IDS. A passive IDS does not take any corrective action. It only detects, right? You would use it to monitor and log the activities that's happening, but you cannot correct the incident. Most of the IDS I've seen, all it is just it sends notification when it detects something. Now, you want to use IPS. In the network environment, we use NIPS, right? We call that NIPS. NIPS, so Network Intrusion Prevention System, you would use it to prevent any kind of, occurrences that you don't want on your network. For example, denial of service attack, we don't want that force our bandwidth and destroy our network, right? So we would use an NIPS. And on top of that, you also should use a firewall, right? So we would use several security appliances inside and outside of, at the edge of our network to make sure we better protect our data and network systems. Any questions? Oh, so long today, huh? Hang in there, we're almost done. Okay. All right. BRI versus PRI, ISDN connection. And you ask me, oh, we don't use ISDN nowadays anymore, right? But somewhere in the world, there's still ISDN. ISDN sometimes is used as a backup line in case your cell tower goes down or, your main fiber line goes down. Fiber line goes down, how? They can cut it, something, can terminate it from sending signal. So ISDN was very popular after the dial-up era. I want to say maybe late 90s to early 2000s. Most of you were not even born, maybe. But look at the speed, right? 128 kilobit per second connection. That was fast for us because dial-up was half of that, 56 kilobit per second. And so basically the basic rate interface, your BRI, is made up of two 64 kilobit per second channel, your B channel, and one of 16 kilobit per second control panel known as the D channel, right? In CIS25 books, they might talk about BRI, but more on like, oh, it is an ISDN and this is the rate. Well, networking a lot of time refer back to the communication. So it is ISDN connection. That is the rate, but is made up of a group of different channels. You need to know B channels and D channels. Okay. And B channel is 64 kilobit per second. And D channel is 16 kilobit per second. Any question? No? Okay, I'm gonna move 20, 21 and 22 to the next page, if that's okay with you guys. You okay with that? Like I said, all of this information is also on your notes. And then your primary rate interface, your PRI, a lot faster, right? That's an upgrade. 1.55 megabit per second connection. And looking back now, you guys might say, oh, that's nothing compared to what I have nowadays, right? We're in the giga, not the mega. But that was super fast for a lot of the network back then. So your primary rate interface, your PRI, consists of 1.55 megabit per second connection, which is made of 23 kilobit per second channel. And that's how you group them together. That's how you're able to have more bandwidth. The B channels, you need more B channels. And then you're going to have one 64 kilobit per second D channel. That is a huge jump from 16, right? So you have a 64 kilobit per second D channel for control information. So you often see that the D channel is used for control, which is, you know, different than your B channel, which is going to be consist of most of the bandwidth for ISDN. There are countries in the world still use ISDN. So this technology has not phased out completely. Like I said, for most of our network, this is used as a backup line in case our primary connection is down. Is it secured? Probably not. In security, we always assess what is your backup line. So a lot of people refer to like wireless and other things, but cloud is no good when you have no connection because everybody house their infrastructure in the cloud. So without your infrastructure, you don't have a network, web application database, you name it, servers. So in the case that if that area have earthquake or something happens, you have to have some form of other connection. And satellite is somewhat unreliable because it's line to sight. On a cloudy day, you might not get a lot of really great connection. So there are like, you know, feasible option in what we look at as backup. And so we revert back to traditional technology like this sometimes as a backup line because it's rarely used. Why pay a lot? But ISDN back then, you used to pay for data packages, like how you pay for cloud data now. Like how much you transmit back and forth, that's how much you pay per, you know, per unit. Also sometime, you know, if you use it as a backup line, you would pay based on the hour or the seconds or the time that you use. So, you know, communication company, landline company, they used to charge that way. Similar to dial-up and other things. Right. So, longer chapter today. Okay. Well, let's talk about load balancer. This is important. You need to know its functionality because it is a beautiful thing in the network, right? A load balancer is an appliance. It's able to split the workload to different systems. It's able to determine that, right? Like when you have a congestion in area, if you have a load balancer, it's able to diversify your network traffic. So it boosts up your performance so that way you don't have a bottleneck, which is one system handling requests. When is load balancer used? All the time, right? For web traffic, all the way to, you know, domain access to, you name it, remote access, etc. In a network environment, we won't have a good performing network without a load balancer. So it is a device that's gonna be able to divide up the traffic and allow that traffic to be handled by other systems. So that way we have higher throughput or keep our performance consistent. And in security, we want to make sure our network is available 99.9999%, you know, and our performance should be peak in that area. Now, some appliance has this built in, right? The load balancer capability, but it is also a separate appliance. Let's talk about proxy. So proxy server can be used to handle requests like URLs. Because in the case that if you have a lot of users requesting that, the proxy server can look at the request, filter it, and also if it's already been visited, it can reference it really quick. Proxy server in the security area, we can use it to filter web requests. Like school district would like to use proxy server because they don't want the kids to visit a lot of different websites. Let's say they don't want TikTok. They don't want, you know, YouTube in school district during school time, right? They're trying to ban smartphone being used also. So that means that I can use proxy to be able to set it up. I can also set it up as a filter mechanism on my firewall to create a whitelist of all what's allowed as URL. But it is a middleman to be able to look at the request of the user, right? We can do it for quicker access, or we can do it to monitor. Proxy can be used to monitor, or proxy can be used to filter. It's like placing a traffic cop in the middle at the intersection, right? He's able to control how the traffic's gonna flow. You go left, you go right. Or he can make the traffic goes faster in the case there's accident, right? So proxy can be used in many ways, and we don't just place one, we place many, right? In an enterprise environment, you have many proxy to be able to handle things to give you the resources that you need. I forgot that this one is just as long as the one prior to the last. And then we'll take a break at 7. Now, in security, you can pretend to be a proxy to intercept all the traffic, right? Zach does that. I think some of you took my ethical hacking class or 41A. You probably have seen that before. There are many other tools. I think Burp Suite also does that. You can set up a vault proxy and then direct traffic. So you can screen their traffic that way, right? Just to see what's going on. And then capture some of the information. You could even get some of the more sensitive information. But on the side of the network administration, we use proxy for many different things from what's listed. And virtualization is here to stay. It's not gonna go away. People say, oh, it's old technology, but we virtualize in the cloud, right? Which is on someone else's server, we virtualize locally. Virtualization is the world of IT and security, right? So you have different technology that's being integrated from VMware. You guys are very familiar with VirtualBox and when we started using VirtualBox today. It is a free virtual machine player, but there are other like Kimu and other virtual machine player. But the most common one that you see with Microsoft is called Microsoft Hyper-V. If you are going to be an IT administrator, in that level, I encourage you to, number one, learn cloud technology. Azure is everywhere. Everybody uses Outlook. Everybody uses OneDrive, right? It used to be SharePoint. We call it Azure. And inside Azure, you can integrate virtualization technology. If they don't use fully the cloud, they would also integrate Hyper-V with thin client, which is the lesser hardware. Now, Hyper-V is a type 1 hypervisor. It basically is a software application on top of the hardware. And the host operating system, similar to what you see with VirtualBox, is running as a parent virtual machine, which allows you to control the access, the hardware from the host with the guest system. So the virtual machine is the guest. The host OS is Windows 10 or Windows 11, or sometimes it could also be Linux. But in Hyper-V case, it's usually Windows. So what you have is you need some kind of light hardware. When we say thin client, basically it's not a powerful computer with minimal RAM, very little storage, right? Everything can be clouded, store it back remotely on a server. And so we can push virtualization that way. And this is just to reduce costs overall. So you need a host system that runs some OS and some hardware. You can use your virtual machine to be able to control some of the system, like your USB, connecting to network devices and so on. So make sure we learn about the different type of hypervisor. I think you see that across, right? And then if you guys want to get into AWS, right? I know Amazon has their own set and you can get free training through Amazon as well. It's always good to learn the cloud and also virtualization. I encourage you to. Very important. Because that's almost all you see, right? If you get into security, they're going to ask you too. If you are able to manage and handle security solution in cloud-based environment. And it is a different animal compared to, even though it's remote server, but uses different tool. So there are different cloud, and we have private cloud, public cloud. You can have hybrid cloud. So public cloud is like your Google Drive. You can sign up and then you can send it. You can upload your pictures or whatever you want to save on their server, right? And then we questioned about the ownership and so on, because you have to agree to the term and licenses and all of that, because you store it there. It's like you go and put all your property, your important goods in someone else's house. You're still gonna be reliable on what they have owned, right? What they store for you. So there are some models in the cloud where it would consist of companies sharing storages. And this is done for cost saving, or let's say that I have sister company or partners, right? That I can share the cost with, and this is called a community cloud. Companies that have money, they would house their own data, like data center, like Facebook, right, which owns Instagram, Google, they also house other people data. Having a data center is very costly. So company can share the cost for the cloud service, like for web hosting or whatever web application, you can have a community cloud. So ultimately, when we're implementing cloud, what should we look at? Right? Of course, internet connection or connecting to our cloud infrastructure or cloud storage or service is so important. Without network and internet connection, we're done. No cloud. Then we also need to consider security policy and how the data is accessed based on regulations. That means that we have to be compliant to the industry-based compliant, federal, and local compliant. So we have to look at the laws and the requirements. Because when you house your data in remote area of the country or the world, some of the requirement locally to that region is important. So I heard on the radio on the way in today that TikTok went to court today trying to appeal, right, Biden's law on, they must sell to a non-Chinese company in order for TikTok to be allowed in the United States. How can they control TikTok being used? Something that China is controlling all the other web application that's not China-based, right? State firewall at the national level, simple, right? So they're trying to overthrow the bill, and they were saying that, they don't want to sell, blah, blah, blah. There's all these things. So because all your videos that you upload to TikTok, it housed where? In China. And in China, there's concern about security and how your data is being managed. So that was the main drive behind that particular bill being passed. So when you're looking at cloud data, where it sits in the world as a physical storage, as a server, that can also have pertinence in how we look at compliance, right? Because if that company has your data in Denmark or another part of the world, you gotta take a look at what they require as data security for that region and that location. Even if it's the same company like Amazon or whatnot, right? So that's also important to consider. Let me see. Oh, this one is so long. So you don't have to put this verbatim. Okay, but you can find this in a note. I'm going to move maybe 27 to the next page. Oh, we're at 7 already. I'm behind schedule. Okay. So let's keep it brief for these. You don't have to put it all like this, but you can look at this from the notes. The type of network storage connections, you can use fiber channel, which is often used for SAN, right? Storage attached network. And it uses a special channel fiber interface with the switch. And it is costly. So some people would say that SAN implementation is costly. So uses for SAN. SCSI is called iSCSI. And SCSI technology been around for a long time. This is just an upgraded version for the protocol. Small computer system interface, which is, SCSI, And when you're using iSCSI, your IP packet is sent over the Ethernet to the server storage. So that means that you can use remote storage, which is you can store elsewhere, not physically at and within the same network. And that's mostly that, right? So you have to use specialized software with it. Then you have fiber channel over Ethernet or your FICO, or FCOE. This is why network bus is hard because all of the extra stuff that you have to remember, right? But this is important because if you're dealing with file server and storages, you have to know the interfaces that it uses, okay? So fiber channel over Ethernet encapsulate fiber channel frames inside the Ethernet frame. And ultimately, you don't have to purchase the fiber channel components for the speed of your SAM, right? It lets you use the Ethernet network speed, right? Because otherwise, if it's a fiber, then you have to buy it for the bandwidth of the fiber, which is higher in cost. So as long as you have at least 10 gigabit per second for throughput for the fiber channel, then you're okay because it's over Ethernet, right? So if your existing network is already at Ethernet speed, you can integrate fiber channel over Ethernet for SAM, which is a better solution than going the other ways. And then Infinity Band, which is new, and that is upgrade from your FCOE. It is gonna be higher in speed for connection with components. Any questions? So all of this allows us to have various options in how we use SAN or SAN, right? Storage attached network. And, you know, every company have some kind of network that would just handle data storage in general. Because data is huge and it costs, right? And you know this with a lot of the free web application. At first, it's free for the first couple of years. And then when they have more popularity and use, they start charging because server has to house the data and somebody has to pay for the costs, right? Even if it's $10, you know, and it gives you a certain amount of cloud storage. Just like how the network diagram thing that we were using, right? They give you 2 free diagram and then the third and all the subsequent. Well, they have to house the data somewhere, so somebody has to pay for the cost, if not the user, right? And then for 29, the benefit of jumbo frame. And I talk about this, I think, in another class as well when we cover 41D. Jumbo frame usage is when you send huge amount of data, right? Like lots. When does this happen? A lot of organization needs to do this. Financial industry, when they need to set up batch job, update transactions, all of those things. Different things for different industry. So jumbo frame reduce the overhead when you're sending a large amount of data, such as sending one frame at 9,000 bytes instead of 6 frames in the smaller chunks. So that just means that, you know, instead of doing 6 frames, you can do 1 large frame in data. That's called a jumbo frame. And SCADA is a system that is used to do a lot of different things, from managing power usage to air conditioning to manufacturing. In production plants, SCADA system is used to monitor and manage equipment overall. Like, I can use SCADA to turn on all the parking lot lights and all the plazas that I own. I can use SCADA to make sure that all the air conditioning system is activated in all the manufacturing plant that I own. So SCADA is a way that we can centralize management in resources that we use for facility and production and manufacturing. You often see a lot of that. So industrial control system, that's SCADA. There's a huge area right now that lacks security. Use 2. I don't know why I put 2 can. So when you look for job, right, and they would say cybersecurity analyst that has knowledge in industrial control system, and then following that IoT devices, right, embedded system, microcontroller, testing, all of those things. So this is advanced manufacturing, and a lot of that ties back to security area, because supply chain, without it, we collapse. So and then the type of system of a network that is been optimized for voice, video, web pages, and other forms of media that deliver rich media experience to the user. You don't hear this term referenced a lot, but there's a name called media nets. So anything that deals with media-based, voice, video, website, which is called media nets. So when you installing cable, right, electricity signal-based system also generate heats and other things. So what you can do with some cable, when you run it beneath your floor gaps and ceiling gaps, you notice that a lot of time we don't run cable across the ceiling where it's visible. That might be okay at home, but not at a business environment. So what you can do is you can use a certain type of fire retardant based cable system or coating. And plenum grade cable will allow that. So it would reduce the chance of catching fire in the case if there's a lot of heat. Or, you know, flammable area. So why should you use plenum grade cable? It's because of the toxin that would release from the polyvinyl. So when you guys strip the cable, right, that plastic coating, that's the vinyl coating for the cable. And so in the case where if you want to use plenum, that's also reduce the toxin, which causes fire. So you want to use certain type of grade of cable, especially when you bundle them together, and if they're in like a closet, and that can generate a lot of, you know, it could be flammable, it could be hot in case it catches fire. So we always want to make sure that it's not going to do that by using a certain grade. Okay. I forgot that this is so long. Sorry. I just remember recalling that when I record this for my online 40A, it was 3-4 parts. Okay. And then let's talk about patch panel. I think I have a couple in the back. Maybe I can roll it up in the middle so you can see. The patch panel allows us to connect to the network. Some racks would have, appliances. So this is the switch on the top, which has a bunch of ports connected, and this is the layer 4 switch we talked about that. I'm gonna roll this around. You guys can see like the top one right here. Right, we would see that there's raw clips to the wires, right? So patch panel, often you would have like the color coding and some white clips. I'll push it up for the ones in the hot section. So that's a patch panel. And you can attach this to, mount it to a switch like this. This is a rolling switch. We don't do this real lot. We put it into like the racks in the back there. But that allows you to wire like fibers or even copper wire directly into it without the connector. Right? So you can attach it. It's a panel that you can attach to the rest of your network. And then in the front, it would have port connection just like a regular system, right? A label. But in the back, it just flips to the actual raw wire. That's what you see compared to what you see in regular. So if you guys want to see. Right, so this white part, so the difference between a patch panel and switch, this part. You would see these clips, and it would have the coding for the raw wire that goes to it. And you would patch this to the rest of your rack because the front of it has ports like this. Yeah? So I can go port 1, do a switch, I don't know, port 15. But in the back, I can put like fiber wire or copper wire, depending on the network, that structure or media I use. So that's a patch panel. So you have the horizontal cross connect, which is HCC cable that's used to connect to the patch panel. And then the vertical cross connect, right? So the horizontal cross connect, it's gonna go across horizontally from one to the next, where the vertical cross connect's gonna go up and down. So the VCC, and that's used for MDF and IDF. Now, you should always label. The more organized you are in the network, or anything, I talk to my students about ethical hacking, all of those things. Forensic, right? The more organized you are, the better it is for you down the line. So you should do what for label? You should label your ports. You should label your system, right? With sticker, however you want to label, right? You should label your circuit on the patch panel because I have a bunch of numbers in the back, right? You can see back here. And I might know today and this week because I integrated it, but 4 years from now, when I need to troubleshoot it, I'm gonna forget what goes where, okay? So some people, they would use marker and label the top, permanent marker. I've seen that, but as long as you can read your writing, because when I was an administrator and I went in there and I looked at the patch panel, I could not read their label, so I made them relabel it. So you need to make sure that you label what goes where for your patch panel. You need to label your system, your ports. The more clear you are, the easier it is for you to troubleshoot and find things, especially when it comes down to the problems that specific day. Okay? All right. So leave it up here if you want to take a look. There's some rolling racks in the back as well. We'll use this later. Okay, let's take a break, bathroom break. I opened the door for water if you need. I did replace the water bottle in there. Let's stop recording and then we'll do the lab. You're gonna need a drive. If you're done with the drive and copy, you can share it with someone next to you or near you.